in this video, we are going to take a look at this question. It says that the largest value of the positive integer k for which n to the power k plus 1 divides this expression. So we have to find out what is the largest value of positive integer k for which this particular expression n to the power k plus 1 will divide this whole thing. This expression is 1 plus n to the power 1 plus n to the power 2 so on till n to the power 127. So the first thing, okay, as soon as we see this kind of expression, we should know, okay, that we are dealing with a GP, right? This is a GP, okay, from the first look, because we can write this as nothing but n to the power 0 plus n to the power 1 plus n to the power 2 and so on till n to the power 127, right? So basically this is just multiplication of n, right? Every term we are multiplying one n to the power 1 into n is n square into n is n cube and so on. So basically the first term of our GP, okay, is a, which is equal to 1, okay, in our case, and common difference r is going to be n, right? So these are the two parameters for our GP. Now, so let us represent this expression, okay, properly, okay, as the sum of a GP. So what is sum of the GP? Sum of GP, I'll just write the formula here. It is given as a r to the power n minus 1 upon r minus 1, right? So this is the expression for sum of n terms of a GP, right? Sum of n terms of a GP. So now what I'll do is I'll put this expression, okay, in this form, and then we'll see, okay, how we can figure out what is the largest value of k. So I can write this sum as a is 1, r to the power n minus 1. R is nothing but n, right? So n to the power. So n to the power, it is going to be what? 128, okay, minus 1. So this n is not the same n, right, which is given in the question. Here n represents the number of terms, right? This n is actually the number of terms, right, in the GP. So we have 128 terms in the GP. So basically for this value a is, and here I can write, right, n is 128 terms. So these are the three parameters, right, a, r and n for the GP. So n to the power 128 minus 1 upon n minus 1, right? So this is the formula for the GP, and we have just placed, okay, all the values a, r and n. So this is what we get. Now what we can write is n to the power 128 minus 1. Can we write this as n to the power 64 whole square minus 1 whole square upon n minus 1? We can write it, right? We can write it like this. 128, we can write it as n to the power 64 whole square. So now just apply a square minus b square, okay, in the numerator we have, okay. So what we will get, so let me take a fresh slide and let us write it down. It will become very simple after this. So let me write this down here. Some different slide came up, okay, this one, right? Okay, I'll just clean this, okay, and then we'll see how to do this, okay. Let me clean all of this, delete, okay, right. Now, so where were we? So we had this thing, right? Okay, so now we had this n to the power 64 whole square minus 1 upon n to the power n minus 1, okay, this we had. So this 1 square you can write, right? So this you can write as n to the power 64 minus 1 and n to the power 64 plus 1, right? We can write it like this, and this is n minus 1, right? Okay. Now if you see, we are getting n to the power 64 plus 1, right? And here if you see, what are we getting? So we are getting, so basically n to the power 64 plus 1 we wanted, right? And this is what is n to the power k plus 1, right? So if you are having some problem like, okay, the denominator is also there, okay, and we're not sure whether it will actually divide or not, so we can write it in even better way. So you take this whole thing together, right? And we can represent this as one term. So what is this? This is nothing but sum of 64 terms of the GP. Okay, n to the power 64 minus 1 into n minus 1. Can we not write it as 1 plus n to the power 1 plus n square till n to the power 64 terms, right? So n to the power 63. So this whole thing, okay, that I have put in the circle is basically this expression, right? Sum of 64 terms of the GP, and this is n to the power 64 plus 1. So essentially, I can say that my final expression is nothing but this, right? So from this, I can clearly see, okay, that n to the power k plus 1, the biggest value of this, okay, the largest value of k from this is nothing but 64. So our correct answer is 64. Thanks.